We're going to move on to the next lesson, which is section 8.1. And we are going to work on finding angle measures in polygons. We're going to talk about interior angles, which is what this video is about, and then I'll have a second video on the measure of exterior angles. Okay, let's do a definition first, and actually I want to sketch a picture to go along with this. This says that a diagonal of a polygon is a segment that joins two non-consecutive vertices. So non-consecutive means not right next to each other. So if I take this polygon, I don't know, let's just draw 1, 2, 3, 4, maybe I'll draw like a 5-sided shape. So if I draw a diagonal, I'm going to connect two non-consecutive vertices. Now vertices are where the sides come together. So there are 5 vertices here. These two vertices are consecutive, okay? They're right next to each other. So if I draw a segment like this, that is a diagonal, okay? I could draw another segment like this, okay? So these are diagonals. I'll just kind of point to each of them, I guess. Okay, so those are considered diagonals. So you could draw a lot of diagonals. We're going to have a lot of properties about diagonals in shapes. So it is connecting non-consecutive vertices. Because I guess if you think about it, look at what happens if I connect consecutive vertices. Do you see how I've just created, like drawn over the side of the polygon? So that's why they have to be non-consecutive. Okay, so I just drew 2 examples there. All right, we have our first theorem. I want to kind of go through an explanation to help you really remember the theorem. If you remember how the theorem is created, you might be able to recreate it on your own. So we are trying to determine here what the sum of the interior angles, what the sum is for any polygon, any number of sides. Okay, so I'm going to start with these shapes down here. So I'm going to start with a triangle. Of course, we already know that a triangle has 180 degrees. So I'm going to kind of jump back and forth between this section and then this section. Okay, so I'm going to be right here for a minute. Triangle has 3 sides. So the number of triangles. So I cannot take this triangle and create any more triangles inside of it. So I'm just going to say here that there's really just one triangle if you have a triangle. And then we already know that the sum of the interior angle measures is 180. We worked a lot with that in earlier units. Okay, now a quadrilateral, what we can do is we can break these polygons into triangles. Okay, so if we know that one triangle has 180 degrees, then however many triangles are in the shape, we can then use that fact that they all have 180 degrees. So I'm going to take this quadrilateral and draw a diagonal. So I have clearly created 2 triangles. So let's go back up to this row right here. So if I have a quadrilateral that has 4 sides, then I can break that quadrilateral up into 2 triangles. Okay, so let's jump down to the pictures again. Let's take this pentagon. And I'm going to just start at one vertice, maybe this one, and I want to draw as many diagonals as I can. So from this one vertice, I can draw just 2, because if I draw any more, I'm just drawing over the side. Okay, and so what I see here is 1, 2, 3 triangles. Okay, back here on the quadrilateral, I only had 2. So back up to my table. If I'm dealing with a 5-sided shape, a pentagon, I can break it into 3 triangles, okay? And then let's do one more with hexagon. Pick a vertice, I'll just pick this one, and I'm going to draw as many diagonals as I can. I can put one there, I can put one there, and then I can put one there. So I have 1, 2, 3, 4. So back up to my table, there are 4 triangles. All right, so let's go back to this column here, the sum of the measures of the interior angles. So I can create a formula here. If I know that all triangles have 180 degrees and a quadrilateral has 2 triangles, well, if I take the number of triangles times 180, then I know that is 360. So in all quadrilaterals, there are 360 degrees. And you may have known that triangles and quadrilaterals are pretty common, so we remember those two the easiest. But let's keep going with this formula. So for pentagons, there are 3 triangles. Each of the 3 is 180. So if I take 180 times 3, I get 540. So all pentagons have an interior measure of 540. Now what I'm talking about here is if I were to take the angle over here, plus this angle, plus this angle, plus that one, all 5 of those angles add to 540 degrees. Okay, hexagons have 4 triangles. Well, I need to take 4 times 180. That would be 720 degrees. So this angle here, plus this one, all 6 of them add up to 720. Okay, so I don't want to have to draw triangles for all my shapes. I don't want to have an 8-sided shape and draw triangles. So let's come up with a formula. So I want you to notice the relationship between the number of sides and the number of triangles. So can you see there are always 2 fewer triangles every time? Okay, I'm going to write here 2 fewer. So if I want to represent 2 fewer than n, I'm just going to take 2 away from whatever n is. So, apply it here. 6 minus 2 is 4. Let's say that n is representing the number of sides. 5 minus 2 is 3, and so forth. Okay? So notice what I did over here. I did the number of triangles times 180, number of triangles times 180, number of triangles times 180. Okay, well, let's keep going. I'm now saying that the number of triangles of any polygon is the number of sides minus 2 times 180. So if I had a 15-sided shape, I could take 15 minus 2, which is 13, times 180. That would give me the interior angle sum. Okay, so you can always fall back on, well, how many triangles are there? I think there's 2 fewer. Then I can multiply that by 180. Okay, so what we just talked about is the theorem. So it's called the Polygon Interior Angles Theorem, and it says that the sum of the measures of the interior angles of a convex n-gon, so any number of sides. So I've got, measure of angle 1 plus measure of angle 2 all the way up to however many sides is the formula n minus 2 times 180. Okay, so this is we're looking for the sum, the total. So if I want the total, I can just plug it into this formula. Now we do have a corollary. Just because quadrilaterals are so common, the sum of the measures of the interior angles of a quadrilateral is 360 degrees. Okay, now you can calculate it. You can come up here and think about, well, there's just 2 fewer triangles than sides, and so I know 2 times 180 is 360. You'll probably remember, of course, triangles, but you'll probably remember quadrilaterals is 360 and pentagons is 540. Those are the 3 ones that are pretty easy to remember. When we get past that, we normally fall back on the formula. Okay, so let's move on to some examples and utilize some of these ideas. All right, number 1, find the sum of the angle measures in a polygon. Okay, this is my key word right here. Okay, so the formula we just talked about is for the sum, the total of all of the angles. All right, so I know that this was in our table, okay, but let's take a look. Let's just think about, if this were a shape we weren't familiar with. So I need to know how many sides are in a hexagon. So I'm going to call number of sides. Now I can count them in my picture. There are 6. So to get the sum, I need to do n minus 2, or the number of sides minus 2 equals 180, or times 180. So 6 minus 2 times 180, of course that means I'm doing 4 times 180. And so 4 times 180 is 720 degrees. So it is asking for sum, and so that is my solution, the sum of the angles. Okay, number 2. Number 2 says the sum of the measures of the interior angles of a convex polygon is 2,700 degrees. Classify by the number of sides. So I know that the sum is 2,700. So classify by the number of sides. I want to know, is it a triangle? Is it a hexagon? Is it a dodecagon? You know, I want the classification is using that vocabulary. Okay, so the sum of the interior measures is the formula n minus 2 times 180. Well, I already know what the sum equals, all right? So I could just solve this equation for n. So you could do one of two things. You could distribute in 180. Okay, so if I distributed in 180, I would have 180n minus 360 equals 2,700. Okay, and so I would add my 2,700 to both, not 2,700, add 360 to both sides. So 2,700 plus 360 is 3,060. And then divide both sides by 180, and I get n equals 17. Okay, I could do another type of solving. So I've got n minus 2 times 180 equals 2,700. So I could start here. I could divide both sides by 180. Those two would divide out to be 1. So that would leave me with n minus 2. 2,700 divided by 180 is 15. And then I would have to add 2 to both sides to get 17. So it really depends on personal preference here. I can do this on this side because I have a number times a number. So if I have multiplication, I can divide off some of that. Okay, classification. I'm up to 17, so this gets that really generic classification. So this is a 17-gon. Okay. Okay, I want you to pause and look at number 3. You are finding the value of x. Okay, when I look at this problem, I am going to add all 4 angles up, but I also need to set them equal to a number. Now, this is a 1, 2, 3. If it's got 4 angles, it has 4 sides. This is a quadrilateral. Okay, so I know that quadrilaterals have 360 degrees total. If I didn't know that, I would run it through the formula n minus 2 times 180, and I would get 360 degrees. Okay, so now I need to add all 4 angles together. Oops, 155 plus 115 plus 2x equals 360. Okay, so I need to really calculate 2 things. Number 1, I need to calculate this number, and then number 2, now I'm calculating x. Okay, so I have 3x plus 270 equals 360. Take away 270 from both sides. I get 90, and then divide by 3. It looks like I get 30. Okay. All right, so this video, I'm going to stop it here before I go on to exterior. So the key element on interior angles is the formula, or the polygon interior sum theorem, where the sum of the angles is n minus 2 times 180. Okay, I'm going to move on and do a second video on exterior.